Hello student, now very most important topic, that is enantiomers. What is enantiomers? Now topic is enantiomer. What is enantiomers? That compound having optically active and non-superimposable mirror images of each other is known as enantiomer. Student, very most important student, what is enantiomers? Compound having optically active and non-superimposable mirror image of each other is known as enantiomers. I gave definition also here. Compound having compound having optically active and non-superimposable mirror image of each other is known as enantiomer. Student, it is very most important. Compound having optically active and non-superimposable mirror image of each other is known as enantiomers. And another point, students, enantiomers have different behavior towards plane polarized light, PPL, that is plane polarized light. Enantiomers have different behavior towards plane polarized light. So means when plane polarized light rotates towards the right hand side, that is called dextro. When plane polarized light rotates towards left hand side is called levo. These are the enantiomers have different behavior towards plane polarized light, that is called PPL. PPL means plane polarized light. And another point, students, enantiomers have same physical properties, but diastereomers are different physical properties. Once again, it is very most important point, students. Enantiomers have same physical properties. Enantiomers having same physical properties. It is also very most important, student. So now here, and now take the example. Here now take the example, that is here one chiral center is this chiral carbon. This carbon surrounding 4 different group is there. So that's why it is chiral center or chiral carbon. This carbon having one hydrogen is there, one methyl group is there, bottom position one ethyl group, one hydroxy group. These both are mirror images to each other. Why? Because of this chiral center, this OH group present on right hand side is there. So that is called dextro compound. The OH group present on right hand side. So here this OH group, in this first compound, one OH group present on right hand side. In second compound OH group present on left hand side. So these also both are chiral center. So these both are mirror images to each other. This OH group, these both are mirror images to each other. So that's why these compounds are called enantiomer. This compound is called enantiomer. So compound having optically active and non-superimposable. So these both are non-superimposable. Why? Because of these OH group, this compound OH group present on right hand side. In the second compound OH group present on left hand side. Both are mirror images to each other. So that's why this first compound is dextro and second compound is levo. So here these are the both are enantiomer. Compound 1 and compound 2 both are enantiomers. Both are enantiomers. So simple trick, student. So how to identify that compound is enantiomers or not? So compound having optically active and these both are non-superimposable mirror images to these both are mirror images to each other. So this is act as mirror. This is middle line is act as mirror. So these both are mirror images to each other. So and one more thing is these both are having enantiomers having same physical properties. So I will take one more example, student. Here only one chiral center is there. So it is easily identify the enantiomer, but in more than one chiral centers are there. How to identify that enantiomers are not? So now take the another example, students. Now take the here tartaric acid. In this compound tartaric acid, here one chiral center is there. This is carbon 1 2 3 4. Here 2 chiral centers are there. This carbon having hydrogen right hand side is there, OH group left hand side is, and COH group. So this carbon having 4 different groups are there, one H, one OH, one COH group, and bottom complete this one compound. So the 4 different groups are there. So that's why it is also chiral center. Though this act as mirror, this middle one is the mirror, and this is second carbon, and third carbon also chiral center. Why? Because of this carbon having 4 different groups is there. Here OH group is there, one H is there, one COH group, downwards one COH group, and top position complete one compound. So this compound having 2 chiral centers are there. So here in first one, this second carbon one chiral center, this chiral center having OH group present on left hand side, but in second this compound one this is compound 2. Here two compounds are there in structure 1 and structure 2. Out of the two, please identify that structure 1 and structure 2. Here OH group present on left hand side in first compound, and second compound OH group present on right hand side. These both are mirror images to each other. These both are mirror images to each other. So these compounds both are OH, first compound OH group left hand side, second compound OH group right hand side. These both are mirror images to each other. And now next one, another chiral center, third carbon, this third chiral carbon, this chiral center, this chiral carbon OH group present on right hand side, but in second structure OH group present on left hand side. These both are mirror images to each other. These both are mirror images to each other. So that's why these compounds are mirror images. So compound 1 and compound 2, structure 1 and structure 2, both are mirror images, to each other, and these both are enantiomers. So this is the simple trick, students. Now take the tartaric acid. Here tartaric acid, here two chiral centers are there. So structure 1 and structure 2 both are enantiomers. How to identify that enantiomers are not means to find out that compound is exhibit mirror images or not. So this compound second carbon chiral carbon, this second carbon chiral carbon OH group right hand side, in second group OH group right hand OH group present on left hand side in first compound, in second compound OH group present on right hand side. So these both are mirror images to each other. So that's why these compounds are enantiomers. So if you like my video, students, please like and share and comment, students. And one more thing, enantiomers are having same physical properties. Both are having same physical properties. So if you like my video, please like and share and comment. Thank you.